Ladies and gentlemen, welcome to the Asset Management and Internet of Things keynote at Interconnect 2015. Please welcome General Manager, Internet of Things, IBM, Chris O'Connor.
Good morning. Welcome. You're in the Asset Management and Internet of Things keynote, and I want to thank all of you guys for coming here today. It's going to be a good session, and we're going to take you through what we're doing, some new things we're doing inside of IBM, as well as give you some chances to see what our clients are doing as well. So I'm not really sure when all of you became interested in the Internet of Things, but the ideas behind it, for me personally, started a long, long time ago. I've always been fascinated by how things work. I was always a tinkerer, right? I built rockets. I had erector sets from Germany made by a company called Marklin. And for me, everything I saw was an opportunity to take something apart, learn about different technologies, treat them all just as parts, and then try to put them back together again. Just like we're doing today with sensors and simple machines, and putting them together to make something new, something better. So 20 years ago or 25 years ago, we didn't call it the Internet of Things, but the spark of the idea for all of us tinkerers was there. I remember when I was in junior high school, 11 years old, my father and I built a solar collector on top of my house where we hooked up thermometers and sensors and a fan, and we pumped hot air into the house when it heated to a certain degree, and we turned it off when the room was warm enough. Right, I went to get an engineering degree after that. And so for all of you that are here today to think about the Internet of Things, we probably all have a lot in common in terms of how we've thought about things as we grew up and about what the opportunity is in front of us. We are the intensely curious people. We're problem solvers, we're inventors, and perhaps more than anything else, we're dedicated to finding better answers with the components we have to everyday challenges that are in front of us. So, this session is for all of us tinkerers. The Internet of Things represents our moment in time. It's a chance to move beyond limiting technologies of the past, unlock new values that you can create in the future, create new insights and new opportunities. And for me, and hopefully for all of you, it's an exciting moment, really, really exciting moment in time to be a part of. So it shouldn't be any surprise to you that Gartner says that the Internet of Things is now the most hyped technology on the planet. So no surprise. And in fact, what did it displace? It displaced big data. So, there's a moment for you, right? We're moving from big data to what do you do with the data, the Internet of Things, right? And it's all about this increased interconnectivity between instrumented devices, where there's a volume of data, and now there's a set of worldwide solutions that we can bring to bear on this, right? So whether you agree with all the exact numbers that people show or not, the phenomena that's in front of us is that there's tremendous opportunity to create new values for a multitude of businesses where physical and digital things are coming together. The growth is exponential no matter whose numbers you use and where you get them from. There's a set of possibilities, just imagine them. The experts all gush about the possibilities that are out there, that as more and more devices come online, that we can gain more and more intelligence and we can gain more and more business value of how they interact with each other. And in fact, that's going to push more and more data online that has to be captured, analyzed, and then transformed into greater and greater insights which unlocks more and more potentials and more potential improved operations. So really, it's not just about the data being generated, it's about sharing it, analyzing it, creating insights, and then designing solutions for how they can interact with each other. So this is what we think about when we see these numbers, is how do we get the value out of the solution, right? So the interesting part is that it's on us. So while Gartner says it's the hype cycle, and by their definition that means it's 5 to 10 years out, the reality is that so much of it is here right now today, and it's very, very real. Right? Devices around the world are talking. They're talking to us. They're talking to each other. Just give it a minute. How many examples of the Internet of Things can you think about? Who this holiday season hooked up their house? Right? I bet you some of you guys in the room and some of you gals in the room did. How many of you ever ordered a cab and had it show up online now? How many of you have something on your wrist that you wave around and it kind of guides their life right now? Have I hit 10,000 today or not? Right? The Internet of Things is around us. It's around us every day. It's around us as individuals. But when you think about it in aggregate, it's around us as a pool of information that really is coming together around different solutions we can provide. And that pooling effect of the Internet of Things and the information is what makes it so interesting to all of us. So it's really, really important that we understand that this is here today. It's not pie in the sky stuff. It's not stuff that's coming tomorrow. We're going to show you a couple real examples later on in this very session with some of our clients and partners that are going to take you through what they're doing. And just to kind of give you a flavor of some of the things that we've done and we've announced that you can see out in the IBM press room, Pratt & Whitney, tremendous manufacturer of components for aerospace and engineering, engines in particular, tremendous amount of information coming off those engines, using IBM analytics capabilities today to be able to reduce those streams of engine data or the stream of engine data into a cohesive set of analytics that then can be used to tell them whether the engine is performing in tolerance, whether it needs to be serviced, and do maintenance on it before anything else has to happen. So, tremendous example. In the public sector around energy, Lisa Energy and the Nordics, connecting wind turbines, right? Variable speed turbines coming in that move with the amount of wind that's out there, right? So it's a fluctuating set of messages that come in associated with the energy that's being produced. And you need to correlate all that information together coming off of those turbines to be able to create steady streams of power that you can reliably deliver to homes and businesses. They're using IBM messaging capability to be able to bring those streams of information in and be able to make sense out of it so that they can be able to create the right set of power and consistency of power that you expect to always come out of the wall or out of the socket. And then last, Kiwi Wearables, right? I mentioned earlier how many of you have something on your wrist. This is a company that specializes in all the new type of capabilities that you might want to wear and you might want to put on. And if you think about what that means, that's their job. What IBM's done with them is we've partnered with them around Bluemix, and we've gotten them a set of development capabilities, some of them IoT specific, but some of them just straight development capabilities that enable them to now quickly, in days and hours, connect what's coming out of their wearables into usable information that they can go bring back to their constituents in interesting life cycles rather than taking months and weeks to design and build new apps as traditionally before. So those are just 3 examples. So with all that backdrop, a little personal backdrop, a little client backdrop, I'd like to welcome you again to the Asset Management and IoT stream. We hope that in this session, what you're going to get with is an understanding of the value of how asset management, which is something we've talked about at this conference for years, is now a part of the Internet of Things. And we want you to understand the transition that we're making. We want you to understand the transition from life cycle management of assets around static things in the past has now become a very dynamic, intelligent, interconnected set of machines and devices that now speak to each other, and asset management and Internet of Things come together as part of the solutions and the capabilities that you can design and you can do. And for us at IBM, That means we need to bring together capabilities as well. And we're working to build you that future of how asset management and the Internet of Things come together. And as you look at some of our examples, some of our clients, and you tour the trade show later on today, we think you'll see some of the things and the work that we're doing to make that happen. So where's the value of all this coming from? And who are we trying to cater to as IBM? What's our focus? If we're moving towards the Internet of Things and we're starting to bring the asset management capabilities with that, along with it, who are we focused on? Well, we're focused primarily on two types of individuals, which broadly encompass many, many industries. We're focused on makers. Makers are innovators. These are people that are building new capabilities based on some increasingly instrumented and intelligent and deeply interconnected world. They're focused not only on what they make, but how they make it, and they make it safely and securely so that it can deliver the value that you want to see. We're focused on operators. After something's made, somebody runs it. It could be the same company making and operating, but we're focused on the operator life cycle as well. And the operators are people that are creating operations, and they're creating complex interactions of systems, focused on optimizing a stream of products that need to work together. And they're combining services and capabilities from products and infrastructures to the delivery of an end service or an expectation that that business has. It could be the delivery of power. It could be as simple as the delivery of understanding whether something's on or off. But makers and operators are our focus. And so when we think about makers and operators, and we think about IBM, we've been talking to these communities for years. So we're going to be taking the journey into Internet of Things into another step. And what we're really excited to talk to you about today, and what we're really excited for all of us tinkerers in the world to understand, is that IBM today, right here, right now, is announcing a brand new division in the IBM structure called the Internet of Things. So a good partner isn't someone who just has good ideas. We think a good partner is somebody that listens. And in this case, we think it's us that have listened to you and have been listening to you over the years and saying, how are we going to get the job done? We have components in multiple different spots. How are we going to get the job done for our clients and our partners? We've heard you talk to us about some of your biggest challenges of what you're trying to connect together. As we've watched the Internet of Things evolve, we've started to put our solutions together in new and interesting fashions. And today what we're doing is we're bringing together multiple components of IBM to form this new division. Specifically, we're aligning capabilities from across IBM. The continuous engineering capabilities that so many of you may have known in the Rational portfolio, that's aligned for the delivery of smart and interconnected products. The asset management capabilities that so many of you know as Maximo, coming together for the management of complex systems and their life cycles. Analytics capabilities as the holding company or the parent organization for this new division, so that we can bring in data and life cycles insights and apply analytics on top of it as a natural part of the way we build solutions for you, or that you choose your solutions from us. IoT foundation capabilities. For those of you following IBM and the Internet of Things, you'll know that we launched on our Bluemix cloud last year a set of programming capabilities for the Internet of Things that allows you to collect information, bring it into a time series database. Bringing that capability in here as well. It's an exciting new capability of how we can acquire information from any device, anywhere. And then last, facilities management. Across multiple industries today, the notation of maintaining a facility, such as this one, is one of the things that we've done well, and we've been best of class in the industry. We bring that in here as well as part of the Internet of Things lifecycle, because we know that so much of what you want to do when you make and you operate depends on the facility in which you reside and how you do that. So we're bringing these capabilities together, forming a new organization. You'll see some new signage when you walk through, and if you scratch your head and say, what are they doing? We've formed a new group. We're bringing together capabilities that we think you've told us to bring together for years, and we're applying our engineering talents and we're applying our solution skills to be able to make that happen. So if you think about what that means, this new structure enables us to provide for you solutions that we could not easily provide to you before. We can, in one place now, connect, collect, secure, analyze, and provide a myriad of actions, whether that's asset management or whether that's facilities management or whether that's an engineering life cycle or future things we want to do around connected vehicles and cars that you'll see out there on the trade show floor. Go see the Tesla, by the way. If you haven't gone and seen the Tesla, go see the Tesla. So we want to align these capabilities, right? And so this alignment lets us create solutions for you that we couldn't do before. And so regardless of who you are, if you're thinking about the Internet of Things now, we want you to be able to come to us and have us work with you, with our experts, on the solutions you need and be able to address the Internet of Things challenges that are out there in the world today. We've assembled more than just a set of software assets. We've assembled skills, industry skills out there around the world to help you design and understand the over 6,000 clients that this new unit already is taking care of and the types of patterns and the types of things that they do today. So we've brought together the right field focus to offer you a step-by-step guidance that can help you turn the potential of the Internet of Things into real delivery. We're going to show you a couple of our clients later on, and they're going to talk to you about things that are real. And then you're going to hear them talk around capabilities as well as a demo, where we're talking about cloud capabilities, analytics capabilities, the notion of security and integrity, of understanding how to make things more reliable. And of course, the software solutions and components I already talked to you about will be a part of this, with our expertise in business model transformation capabilities put on top. We intend to be an active partner in your transformation of anything related to the Internet of Things as you look forward. As a last example, let me talk to you about one of our most prolific examples of Internet of Things. If you've ever seen Car2Go, you see the little car sitting on the side of the street, and you always wonder, gee, I wonder how they operate that in the background. Well, IBM was a prime partner with Daimler, the parent company of Car2Go. And in the automotive industry, they see this switch from owned to leased to service as a critical switch or a critical change from just being the manufacturer of an individual component or a part. So think about Car2Go, 26 cities in Europe and North America, 12,000 cars, 800,000 users and growing, of people that can walk up to that car, be able to connect to it electronically as a service, and be able to drive it away. And the entire time in the background, the owners of Car2Go can look at it and know exactly where the car is, whether it's secure, whether it's safe, whether it is ready to go, and who should use it and how to get them there along the way. This is bringing together physical, digital, solution, services aspect all in one. And IBM was a prime partner with Daimler in helping make this all a reality in terms of the delivery of the capabilities and the worldwide service of how that is actually delivered. We see these as prime Internet of Things oriented capabilities that were born in asset management from all of our work that we've done for many years, born in continuous engineering from all of our work that we've done for you in years, coming together in now a life cycle of services that we can deliver. So, in conclusion, we're trying to cut through the hype. We're trying to get through it all. We're trying to help you guys understand where you can go today. And with that, I'd like to just kind of move on to the next part and bring some real stuff up here to show you what's going on. With that, Brett Greenstein from my leadership team, Kevin Massey from Cummins, are going to come up and they're going to talk to you about the Internet of Things, and they're going to talk about how it makes and transforms their businesses. After that, Pete Carnes, also from my leadership team, with Les Eisner from the University of South Carolina, are going to talk about the Internet of Things and how it helps operators maximize their assets with predictive maintenance on some very important devices that are used around the world. So with no further ado, let's go ahead and get started. And Brett, come on up and take us through. Thanks.
Thank you very much, Chris. Our first destination today takes us to Columbus, Indiana, the headquarters of the world's largest diesel engine manufacturer. The Internet of Things is a reality for the automotive and industrial applications which are poised to define a connection to a machine, to an operator, and its operations. Think about the possibilities. Trucks that are interconnected with each other, traffic signals, and the very roads on which they travel. or vehicles that couple vast amounts of historical data with real-time data in motion to predict component failure and renewal requirements, alerting the owner and related dealer of critical conditions, corrective actions, and available appointment times. The Internet of Things will not only be used to enhance the driver and passenger experiences, but will also be deployed throughout the value chain to inform product design, speed product development, improve safety, streamline production, reduce recalls, all in a continuous cycle of continuous engineering, bringing together the essential roles of product engineering, asset management, and the IT teams that bring it all together and pulling this all into the forefront of our businesses. That's why many manufacturers are looking at changing the way they work, changing the way their customers work with them, with their products, with their business. It's about changing where they're going and how they get there. So here to talk about this with a real-world example is Kevin Massey from Cummins. He is the Principal Technology Analyst for Telematics. So please welcome Kevin to share his story.
Thank you, Brett. At Cummins, we've dreamed about the possibilities of automotive and industrial technology for decades. These machines, like tractors, semi-trucks, dominate our illustrations of the future for our consumers. These ideals have long been centered on machines that are self-enabling in some way and able to configure themselves to the driver or operator and the environment. Today, these industries come in support stand at a threshold, exceeding what was considered unrealistic just a few short years ago. A machine that connects to the Internet of Things and can go so far as to operate itself. Intelligent machines can support, help, advise their operators and owners to execute tasks like hauling goods and loads across country to moving raw materials in a mine more efficiently and become more responsive to their surroundings. These machines become directly integrated into companies' operational systems. These are machines that can make a difference. All of this makes it a very exciting time at Cummins for the Internet of Things. Cummins has been exploring this opportunity long before it was even referred to as the Internet of Things. This type of technology has been of great use for many years in areas such as manufacturing, health and safety, and engineering at Cummins. The Internet of Things in these areas have mostly been small and localized in scope, ranging from active RFID technology to smart sensors and smart machines that send and receive information for a particular manufacturing plant or building, and usually set up to feed one particular task. But all of these years of work in exploring this technology brings us to the most exciting thing we have today, which is this, our engine. At Cummins, we have explored the potential of the Internet of Things, or connected systems as we call it, over the past few years, and recently something has changed. We are now experiencing an explosion in customer and consumer demand for data that thankfully converges with technology and business readiness that allows our things to become more vital in our customers and Cummins' information flow. Make no mistake, this journey to position our engine among the Internet of Things has not been an easy one. Natural business complications do exist, and we have to find a way to overcome them, along with finding solutions that take the business landscape into consideration. The nature of our business alone being one of these complications. Today at Cummins, we have presence in over 190 countries, produce over 1 million engines a year globally. We serve automotive and industrial marketplaces and sell engines ranging from 2.8 liters to 95 liters. Our engines are in everything from semi-trucks to excavators, backup power generators, and locomotives. With this wide variation of engine types and a broad reach of customers, advancements in technology have been key to our success. Advancements in big data analytics and real-time computing engines have allowed us to make information more readily available across our value chain, to providing real value to our end customers around the globe. By providing real-time and aggregated information and analytics from our engine, our customers are combining this with operational data from their vehicles or machines to make smarter, more informed decisions about their business. Today, we have customers that can use Cummins data and analytics to better understand how the engine in their machine is performing and receive critical event information to better optimize their repair schedules. While all the technology that's used in making our connected system solution new and exciting, the real star of the show is the data. It's easy to get lost in the complexity of making all this happen, but keeping the end in mind is what has allowed us to progress over the last few years in bringing this to market. It's the data that empowers our customers and allows Cummins to bring years of engineering expertise to the analytics. Today's customers demand data and much more data. Summary data, detailed data, data about the performance of the engine, data about when to service their vehicle. But they don't just want any data, they want the right data. The data customers want is the information that's been distilled so decision-making and cost savings become easier, allowing them to become more efficient in areas that directly impact their bottom line. Advancements in mobile and web technology have empowered our customers, so they're expecting more from Cummins. Our customers, like almost everyone's customers, can look around in their own home, in their own car, and even in their pocket or on their wrist to see that getting the right data is meaningful, it's empowering, and it's necessary. Enabling and empowering customers with data is no longer a customer delighter. It's becoming table stakes to do business. As an example, the first application built on our platform is Connected Diagnostics. This is an application where we collect fault information from our engines in real time as a stream. Then we pass the streaming data through a proprietary Cummins algorithm and send Cummins genuine information and recommendations to the customer as well as to our Cummins Care. This information helps our customers manage their assets for peak productivity and efficiency and allows us to more proactively communicate from our Cummins Care network. The data is not just meaning for our customers, it's also empowering to us at Cummins as well. The data we get from our products and operation today allows us to make predictions about the future. It also allows us to see our products from the perspective of the end customer and how their use cases can change over time. Utilizing this information will empower our engineers as they work on the next generation of Cummins products. One of the long-term goals in enabling our engine to contribute as an active participant in the Internet of Things is to provide our customers with a better product that empowers them to become more successful in their business. By securely combining data streaming from our engine with operational and environmental information, internal and external, we can see what influences how our products are used and how Cummins might adjust accordingly to aid in our customer success. The future is very bright for the Cummins Connected Solutions program, and we have no shortage of use cases. With the convergence of technology and business cases, we see the Internet of Things as truly transformative in improving our operations, integrated into the engineering of our products, and the expansion of our services. We must all learn how to translate this ever-growing global network and ideas and things into something that makes our business more profitable and then make sure we're in a position to accomplish it. Thank you very much. I now welcome IBM back to the stage.
Good job. Another hand for Kevin. What a great story. Well, good morning. My name is Pete Carnes. I'm going to be your tour guide for the next 10 minutes or so, giving you an example of one thing Chris talked about, how we're bringing capabilities together to make the IoT work for you. And my key takeaway from Kevin's talk is that of a journey. Cummins, like I suspect many of you, are on a journey to achieve better outcomes through business transformation. Better outcomes for makers, your manufacturers, enabled by the delivery of new products and services, or for operators, through the optimization of your existing maintenance and operations processes. For the past 2 years, in this forum, and in many of our dialogues through the year, we've talked about 3 disruptive forces that are impacting asset management. The increasing complexity of the assets we have to manage, embedded systems, connectivity, et cetera. Growing pools of data that's often disparate. What do we do with that? And how your workforce is changing. Generational turnover, the impact of mobile technology. The combination of these 3, as Chris talked about, relates directly to your organization's Internet of Things agenda. But as Chris and Kevin outlined, IoT is about opportunity that's there today for you, but also for your competitors in your marketplace. And the opportunity is there based on the utilization of these disruptive forces. So, along with my friend Greg Knowles,
we're going to work through a brief demonstration to illustrate an opportunity that the IoT provides for asset management professionals. So let's get started. This scenario builds from where many of you are today, a strong foundation of asset and facilities management with Maximo or Trariga to utilize operational data, in this case on a new asset on a production line, to enable a condition or predictive maintenance approach. The simple example is going to use a new production line torque machine, but could equally be applied, right, Greg, to any equipment and you're building your plant or your rail infrastructure, whatever it might be. Everything we're going to show you today is available and is in use with clients, and we're also announcing a new IoT zone on Bluemix. Now, this houses a growing library of IoT services from IBM and from our partners for you to use to build and construct new IoT apps that stand on their own, but also to enrich what you're doing today with Maximo, with Trariga, with your continuous engineering. So this demo, and by the way, don't check it out right now. We can wait till we're done. It's pretty cool. And it's on display in the expo hall as well. So let's talk about the demo. 5 steps, right, Greg? We're going to connect securely to a new asset. We're going to compose a process flow that's going to tell the data what to do, send it for analysis. We're going to analyze the sensor measurements using predictive modeling to forecast failures. We're going to automate the creation and dispatch of a corrective response. And then we're going to utilize new mobile applications to accelerate repairs and reduce mean time between failure. So great. Let's take the first step. I'm going to ask you to assume the role of a business analyst, where your team is looking to improve the performance of the new torque machine. Within our IoT zone on Bluemix, we're using the Internet of Things Foundation to connect to the asset securely and collect data to feed the analytics. So that's going to be our starting point. Greg?
Okay, thanks, Pete. The data streaming from our torque machine is captured through an intelligent gateway developed by Intel, one of our Internet of Things ecosystems partners. The gateway collects and processes data at the edge of the network before sending it into the cloud. Of course, we could also use data from other sources, including SCADA, OPC servers, and historians. As you can see, we've already connected the torque machine, and we see 3 properties streaming in from our asset: temperature, velocity, and angle. We're only monitoring 3 properties for our scenario today, but in other situations, we may be monitoring hundreds of simultaneous sensor readings across a large number of heterogeneous assets in the field.
So now that we're able to see the live stream of data from the torque machine, we want to define business rules for this data. We want to tell it what to do, where to go, to help achieve the desired outcome. So Greg, staying in the role of a business analyst, can you walk through the step?
Certainly. Using services available in our IoT zone in Bluemix, Pete, we've set up logic to detect when an unusual set of sensor patterns occurs in our asset, in the torque machine. The flow that you see here collects data from the torque machine, sends it to IBM Predictive Maintenance and Quality, where we run big data analytics against the streaming data to forecast asset failures and other conditions. We've configured and trained the models to look for early signs of wear on the torque machine using the 3 properties that we saw in the earlier screen. Predictive Maintenance and Quality identifies an issue. When it does, it also makes a recommendation about what we should do to correct it. We use the recommendation to automatically create a work order in Maximo over here. This works with either our Maximo Cloud offering or with an on-premise deployment like many of you have today. Maximo then combines the details from the asset and the identified condition with the appropriate job requirements, including people, parts, and tools, to schedule and dispatch a repair technician to respond to the issue. And then Maximo pushes the work order out to Maximo Anywhere to accelerate the repair. We can also configure this flow in the top half here to send a text message to our operations and maintenance supervisors through a mobile push service. So I'll link in 2 new recipients into the flow, and I've connected up the end-to-end flow, and once I deploy it, the entire flow will be running live. It's that simple.
That's right. And unlike status reports, predictive analytics use models, right? Models based on historical patterns of past failures to determine the likelihood of a future failure given the real-time data that's now coming in. So predicts the failure, but also forecasts when it may occur within a range. Now, the models produce a health score for the asset, but also a recommendation on what corrective action to take. And that's key. We want the insight and the action. The recommendation is based on a manufacturer's recommendation and known best practices for dealing with the identified issue. So when a failure pattern is detected, the recommendations made with the corrective action. So Greg, changing your role now to the engineering professional. Can you walk us through how predictive maintenance and quality helps asset managers?
Certainly. Let's start with a look at the operational dashboard. The dashboard shows an active production line with a number of assets, including our torque machine. The stoplight colored dots represent the likelihood of failure in near real time. This may look a lot like a typical dashboard, but keep in mind that the warnings are all predictive in nature. That means it's giving you a future view of the health of your assets and the entire production line. The green lights we see indicate equipment that's healthy and expected to operate normally. A yellow dot indicates equipment that may require attention over the coming weeks. But the red dot we see down here on our torque machine indicates that a failure is imminent and it needs near-term attention. From the dashboard here, we can drill down and see a little bit more detail about what's going on. I selected the torque machine, which has a red indicator. That means that it has a low health score and the asset is showing early signs of failure and needs maintenance soon. The bar charts in this view give us an indication of the maintenance interval, and this shows that the maintenance interval needs to be accelerated in order to reduce the risk of failure. A green asset, on the other hand, might show the reverse trend, that we can extend the maintenance interval, delaying associated costs and resource allocation without incurring much additional risk. Now let's come back to the red light we saw on our torque machine. As I hover over the red dot here, we see the live measurements coming in, and we actually see an alert message with a recommendation coming from predictive maintenance and quality. That is to inspect and replace the front rotor bearing. We need to respond to avoid the risk of failure and production downtime. As we saw earlier in the flow, this recommendation automatically generates a work order in Maximo to respond to the issue.
Thanks, Greg. You know, the ability to alter maintenance intervals certainly leads to better outcomes, right? Not only reducing downtime and potential failures, but also reducing costs due to over-maintaining certain classes of equipment, value. So now we're going to shift to step 4, managing and executing the work in Maximo. So I'm going to ask you to shift roles again, Greg, to that of a maintenance manager. So in Maximo, let's look at the work order, let's look at its detail and where it's at in its process.
Sure, Pete. As you know, Maximo acts as the system of record for our assets, managing the entire asset lifecycle, including maintenance processes, spare parts inventory, resource skills, job plans, and maintenance processes. By integrating operational data into Maximo, I can uncover and act on analytical-driven insights to help me manage my assets more efficiently. What you see here is I've logged into Maximo as the maintenance manager, and in the Start Center, we see right away that there's a new work order for our asset. I'll select the work order here so we can see a few more of the details. In the Plans tab, we see what has to be done in order to prevent a failure and service disruption. The job plan associated with the work order shows what tasks are required to repair the issue, the steps to perform each task, and the tools, parts, and skills necessary to complete the job. And, given the high priority of the work request, the automation in Maximo automatically moves the work order into a scheduling queue where Maximo Scheduler matches available resources, assigns the work, and dispatches the technician.
Right. So we're working now.
Absolutely.
So, Greg, so you'd be using Maximo Anywhere now as maybe that field technician, and you'd get a notification, you're ready to start the repair. So as Greg works the issue, he might use a device to scan a barcode tag or an augmented reality chip to ensure he's got the right asset. And he might use voice to text on the phone to capture information to send back for failure analysis or whatever it might be. And upon completion of the maintenance task, he'd indicate when he's finished the work and he'd move on back to his normal schedule. So what Greg and I have shown you here is a very simple Internet of Things example that's real and enables better outcomes in the field of asset management today. From connecting the device securely, to outlining the flow for data, to harnessing the power of predictive analytics, to automatically driving a corrective action to dispatch a repair technician. All about using data to avoid an unnecessary and costly asset failure. You know, if we had time, we could then take this data that we just captured and actually link back to what Brett talked about, back into the manufacturer, back into their process around design, so they can bring out better products faster or address potential service disruptions for their customers. So look, the Internet of Things is all about opportunity. Each of you is starting from a solid foundation of business processes, data, and applications like Maximo and Trariga. Our goal here this morning was to illustrate a simple example, an example of what's possible today to drive those better outcomes. Speaking of outcomes, our next speaker is an expert. Our second destination this morning takes us to Columbia, South Carolina, location of the renowned Condition-Based Maintenance Research Center. Joining us from the University of South Carolina is an expert in condition-based maintenance, spanning a career of 30 years, more than 30 years, in asset management in the United States Army. Please join me with a warm welcome from the University of South Carolina, Major General retired and Deputy Director of the Office of Engagement, Les Eisner. Thanks, Les.
On behalf of Dr. Harris Bastides, the President of the University of South Carolina, Dr. Abdel Bayoumi, the Director of the Condition-Based Maintenance Center of Excellence, the outstanding faculty and staff at the University of South Carolina, and the great IBM team, it's my honor to be here today. You can't always wait until it fails. You shouldn't wait until it fails. You should analyze, you should understand, you should be able to predict why, when, and when it will fail in the future, leveraging the Internet of Things, leveraging data analytics, leveraging actions to create and solve maintenance or predictive asset management problems. This is not a new problem. I'm going to take you back to the 1940s. In the middle of World War II, the British were having a problem with availability on B-24 bombers as they were trying to sink German U-boats. The British military commissioned a fellow by the name of Conrad Waddington to look at, collect the data, analyze the data, and come up with some actions to fix the readiness problems. So Waddington assembled a team of experts, and they analyzed the data. What they found was a lot of the maintenance of the day, the scheduled maintenance, the unscheduled maintenance that was driven by the original equipment manufacturer, and the maintenance regimen of the day were causing reduced readiness rates. And it wasn't tied to any data, it was just somebody said, take the engine off, look at it, and then put it back on, and they had very high abort rates. He had 7 simple things for the British military to adopt. With resistance from the maintenance community, they adopted all 7. Overnight, they increased their readiness rates in a very critical time by 60%. How do we leverage the Internet of Things, predictive analytics, to achieve better asset management or asset maintenance? We must ask ourselves correlated questions linked with data and data analysis to achieve correlated predictive asset management or maintenance. You must question. Sometimes the maintenance trends that we've done for 30 years are actually causing more damage and harm. If you just randomly collect the data without the question, sometimes you will have skewed answers. You must connect in the Internet of Things. You must analyze, and then you must act. In the act part of the equation, we also have to understand the politics of action. If you're in a very regulated environment like aerospace, sometimes the answer and the solution are not intrinsically linked, and it may take a period of time to do policy change to act. Question, connect, analyze, act. The maintenance cost in the food industry account for 15% of the total cost for food today. Maintenance cost for heavy industries such as steel and iron, pulp, paper, represents 60% of the total cost. Recent surveys have shown that 33% of maintenance actions today in the United States are either wasted maintenance actions, improper maintenance actions, or unnecessary maintenance actions. Back to the Waddington effect. The United States of America spends $260 billion a year in maintenance actions. We waste $80 billion a year in maintenance actions. How do we leverage the Internet of Things to reduce and mitigate that cost? I would suggest we're not asking the correlated questions of the data that drives the process to change or achieve predictive maintenance or predictive asset management. We've got a lot of homework to do, and the opportunities are huge. The path to maintenance proficiency has 3 stepping stones. The first is corrective. It's a 20th century based system that is failure based. If it falls off, put it back on, fix it. The second is preventive. Still 20th century phenomena that we're going to probably have to live with for another decade or so, but it's time based. Hours, calendar, fixed time. The third stepping stone to a path to maintenance proficiency and asset management is predictive. It's condition-based. You connect to the Internet of Things, you analyze, and you action. You create an action. You change policy, process, procedure. You monitor in real time the actual conditions. This is not an easy task. It requires education. You have to educate the CEOs. You have to educate the logisticians. You have to educate the maintenance managers, the business managers, to ask the correlated question that the data shows you. The outcome of data analysis must be usable in real time at all organizational levels. Back in the 1990s, I was involved in a project to put in embedded diagnostics on UH-60 Blackhawks. State-of-the-art black box, state-of-the-art sensing capability to do embedded diagnostics and advanced rotor tracking balance. And from a scientific standpoint, it was a success. From a pragmatic standpoint, it was an abject failure. Why? The data was only useful for the engineering community. The operators didn't understand why, the logisticians didn't understand why, and the maintainers didn't understand why. It's got to be useful in real time at all levels, leveraging tools such as PMQ, SPSS, or Maximo. You need to understand the regime that's been used in. My friend from Cummings, you know, we build things, we build engines, we build gearboxes, we build rotor systems, and we deploy them all over the world. Why does one gearbox last 2,000 hours in one regime and the same gearbox only lasts 500 hours in another regime? What is the data telling us? What is the maintenance actions that are necessary to take the 500-hour gearbox and move it up and sustain the 2,000-hour gearbox? Predictive maintenance requires connection to the Internet of Things, to the big data analytics, analysis, and then action. The University of South Carolina research focus at the Center of Excellence is a multifaceted approach to condition-based maintenance and predictive asset management. It's a 17-year success story, which started out as data collection and data analysis to produce a return on investment for embedded diagnostics, expanded to advanced sensing, testing at the naturally and fault occurring level, advanced diagnostics, advanced algorithms. It's become a rich powerhouse. It leverages the power of mechanical engineering, the power of business, the power of computer science in areas such as natural language processing to increase the fidelity of predictive maintenance and asset management. The USC CBM Center of Excellence asked the correlated question based on their years of experience, linked to research to achieve predictive condition-based maintenance. What are the validated benefits of this 17, almost 20 years of research? Direct reduction and elimination of unnecessary parts replacements on Army rotorcraft. Reduction of corrective maintenance. Reduced inspections in the number of test flights. Reduced cost. Increased operational readiness. What are the intangible benefits? Increased safety. Increased confidence. in our ability to do predictive analytics and know what's going on with the aircraft. Increased focus on mission in a military vernacular, increased focus on competitive edge in a business environment. The USC helicopter drivetrain test stand is a systems approach to understanding the complexity of a very complex system and the failure modes to drive condition-based maintenance. What's been the impact of this? Using the data and asking correlated questions, this effort returned the largest return on investment in the history of the Army CBM program, which is a 20-plus year program, of a 20-to-1 return on investment. Huge. The overall economic impact over a 10-year period was $250 million. The cost avoidance over a 10-year period was $125 million. We generated over 9,000 hours of testing on critical components and rotorcraft tied to the original equipment manufacturers and the engineering community from the Department of Defense. Multiple faults were examined, both naturally occurring and seeded faults. Time between overhauls on critical components increased by 250%, a huge savings to the Army and the OEMs. Now I'd like to talk to you about a new exciting venue in our partnership between the university and IBM. It's the University of South Carolina and IBM and Fluor's Center for Applied Innovation. Partnering between what I've just discussed, the rich history of the University of South Carolina School of Engineering and their CBM Center of Excellence, and all the other things that the university brings to bear, tied to the power of IBM and what they bring to provide research and technical assistance for predictive maintenance, condition-based maintenance, asset instrumentation, advanced sensing, leveraging the Internet of Things as we connect, analyze, and act, looking at customer sentiment and requirements as they go out and become economically and business competitive, marketing insight, what is the data telling us? I'll invite you, when you go back on the expo floor, to look similar to the demonstration you just saw. We're going to use real-time aerospace gearbox data collected to the cloud using the Internet of Things to show asset management on a dashboard. Why is this innovation center important? As we've heard discussed today, the power of the Internet of Things, the power of data and the analysis and the action that are driven by it can generate competitive edge, can increase safety, can increase mission capability. So the power between the University of South Carolina Center of Excellence and IBM at the Applied Innovation Center will bring to bear all those fundamentals to increase and achieve predictive asset management. For those interested, and I hope I have enough business cards, I hope there's a lot of interest, I invite you to look at the future with this Applied Innovation Center and the power of what IBM and the University of South Carolina brings to bear. I'll now ask for you to watch a short video, and it kind of encompasses what USC has to offer in this road ahead.
Our focus is global. Known worldwide for our excellence in international business, the University of South Carolina has spent decades developing leaders, preparing them for today's rapidly changing world. We're exploring new ways to enhance cybersecurity, shaping the future of aerospace, and improving the reliability and safety of aircraft through predictive analytics at the Conditions-Based Maintenance Center. And now, the University of South Carolina is partnering with IBM and Fluor to build the Center for Applied Innovation, improving higher education nationwide and sparking new advancements in information technology.
I want to give a big round of applause for General Eisner. And I've got to say that was one of the most inspiring speeches that I've seen in a long time about real impact for real people, for real causes.
Thank you.
And I think it's just outstanding. You mentioned earlier the expo that's out there. I would encourage everybody to go stop by and see this expo. It's hands-on, it's interactive, and it'll connect you in a way that you haven't seen before to the Internet of Things. So I want you to enjoy the whole show. I want you to enjoy the whole conference. I want you to stop by, please see what's going on here with the University of South Carolina. And join us tomorrow morning for the DevOps and Continuous Engineering keynote. And we have 300 other breakout sessions on IoT, as well as a whole set of booths and other agendas out there. So thank you. Enjoy the rest of your conference. Thank you.